flip model, it can work together with text and image data. So basically with the image search, you can eliminate manual categorization of the data. Another most common use case is building Q&A engines. So in the Q&A engines, under the hood, there are LLMs. I'm sure you are already familiar with some of them, like OpenAI, Llama. LLM, basically in the LLM, in the Q&A engine case, you ask a question and you get the answer from LLM with the information it was trained for. In some situation, if you want to get answer for your organizational data or custom specific domain or very specific area data, then you need to integrate a vector store to LLM. So basically you store this fresh data, your organizational data in a vector store, and in the query time, you feed the LLM with the information that is coming from vector store. Let's have a look at the RAG architecture. So in the RAG architecture, you have unstructured data repository. Basically, you have PDF files, spreadsheet, PowerPoints, HTML files, videos, audios, and so on and so forth. And you extract this information, index it, and store in a retrieval area. In the query time, you ask query, and this query needs to be pre-processed, and then it needs to be executed in the retrieval area, and the relevant records from the retrieval area should be fetched, and prompt should be generated. And this prompt should be passed to LLM, and then LLM is going to answer to your question. So we have done some experiments. So on the screen you see an example of 10K documents. So basically, in the United States, publicly traded companies should submit their annual activities to Security Exchange Commission. So this is basically with 10K format. So these 10K documents includes unstructured text with checkbox, with complex tables. There are multiple columns, multiple rows. Some rows include data from other rows as aggregated. And there are some complex paragraphs with bullet points. Imagine that you have millions of 10K documents and you have to build a Q&A engine. And you are asking a query is what's the year-end fiscal year 2018 net PP&E result? This is very specific accounting term for the company 3M, and answer in USD billions. So we explicitly mention what we exactly require. Specific fiscal year, specific accounting term, specific company, and specific format. Maybe the data in the PDF file has been formatted in the million value, but we explicitly mentioned that it has to be a billion value. So if you look at the challenges around the RAG architecture, we would see many challenges on almost every step. While we are extracting data, how are we going to connect to multiple different unstructured data, and how are we going to extract them? During the query time, which embedding models are we going to use? And also during indexing time, which embedding model we should prefer? In the retrieval area, which retrieval parameter we have to utilize? So basically, the retrieval parameter is the parameter that you set while you are getting data from vector store before feeding the data into LLM. And another challenges are which LLM are you going to utilize, and how are you going to verify that your LLM is not hallucinating? So we put all these challenges into a stack where each challenge can be solved by a product or product set that are highly integrated with MongoDB technology and name it as MongoDB Generative AI Application Stack. So at the very bottom of this MongoDB Generative AI Application Stack, we would see MongoDB foundational and embedding models. On top of it, there are model serving platforms. Basically, in some situations, you may not want to host the models. You can leverage some model serving platforms as a service. On top of that, you will see data pre-processing frameworks. So basically, data pre-processing frameworks can help you to extract and index information. At the very core, you could see MongoDB vector database. on top of it, the orchestration layer to connect each pieces between each other. And as a final step, you will see observability and evaluation framework to verify the LLM that is not hallucinating and providing correct reasoning. So if you look at the foundational models, you will see OpenAI, Google AI, I'm sure you are already familiar with some of them. There are two main questions customers ask. Which LLM to be used, and which one is the most cost-effective one, while providing the best accuracy and the best performance. So for the same example, searching some data in 10K documents, PDF files, if we apply retrieval parameter 40, which means that we are actually setting this parameter to mention that we are getting top 14 results from vector store to feed LLM, to provide correct reasoning. We were able to get, we tested 5 models, and all the models provided the correct reasoning, which means that they provided correct answer. Mistral Tiny here provided the cheapest solution, whereas OpenAI GPT-4 model provided the most expensive solution. Between OpenAI and the Mistral Tiny, the difference was almost 60 times. However, there is a catch. We asked the question, we wanted to get the value in USD billions. However, Mistral Tiny provided the answer in millions. So if you want to get the exact same format, maybe you need to evaluate other models here. If we change the retrieval parameter to 13, not 14, intentionally we know that LLM is not going to be fed with enough information and it will not provide the answer. So the expensive models, Mistral Large and OpenAI GPT-4 provided correct reasoning, which means that they didn't answer. It was expected. However, the other cheaper models, Mistral Small, Tiny, and OpenAI GPT 3.5 hallucinated. So basically they provided wrong answers. So the takeaway here is that there is no correct answer. It always depends on your use case. I really like to say it always depends. Because LLMs have different capabilities. Some of the LLMs are very good on the accuracy, some of them are great on the speed, the others are great on the performance. It's your job, our job, to find the best LLM for your use case. Okay, when it comes to embedding models, the same question, which embedding models to be used and which one is the most cost effective. We tested 2 embedding models here. For the PDF search example, OpenAI ADA model, it was the least accurate and also the expensive one. We also tested BG Large open source model, and it provided best accuracy with minimum cost. We hosted BG Large model in 3 environments. First one is model serving platforms. We didn't want to utilize VMs, we just get a model as a service, and it was the expensive solution. If we utilize cloud providers' virtual machines supported by NVIDIA GPU instances, and we reserve the instance for 3 years, we got the most cheapest solution. On top of it, model hosting platforms. I have already mentioned, in some situation, or if you want to do some quick prototype, you can leverage these platforms like Hugging Face, Together AI, Fireworks AI. Basically, you send your data for the query to get the category of the data or the semantic of the data. You don't have to host a model. If you're an enterprise, probably you're obsessed with the data privacy, data safety, and you can try leveraging cloud provider solution. Like Azure, Google, AWS provided more secure environment. You can utilize private link to make sure that your data is not using public internet. You can have always access control on the training data. And and that's it, yes, that's about it. Okay. All right, so far we discussed foundational models, embedding models, and model hosting platforms. So another challenge in RAG architecture is that how are you going to extract the data from different kind of unstructured data? Maybe you have PDFs, you have images, you have PowerPoints. So this is another complex part in the RAG architecture. So we utilize in this example unstructured I/O. Basically, it's a platform that allows you to build pipelines. So it supports more than 25 data types to extract information. In the default loader extractor method, it can get the data from Microsoft Office documents such as Word, spreadsheet, Excel, and so on and so forth. Unstructured I/O also supports advanced OCR mechanism, which means that in some situation, you cannot get the data, extracted data from PDF files directly. You have to utilize OCR models with high resolution capabilities. So that is also available in unstructured I/O. You can utilize it for images and the PDF files. After you extract this information, everything is going to be normalized in JSON records. So JSON is everywhere. So everything is normalized in JSON records, then it's going to be chunked, it's going to be passed through embedding models, then it's going to be stored in MongoDB Atlas. At the very core of GenAI stack, you see a vector database. So MongoDB Atlas, basically MongoDB's database is a service platform running in major cloud providers, along with the capabilities of vector database and vector search. As Boris has already mentioned today in the keynote, it's coming to MongoDB Community and Enterprise very soon. So basically, with MongoDB Atlas technology, you can build the GenAI use cases as we discussed today, semantic text search, image search, and the RAG architecture and more. So you can position MongoDB Atlas in the core part of the RAG architecture, in the retrieval area, with the capabilities of hybrid search, with the capabilities of vector search, pre-filtering and the post-filtering capabilities of the vector search, full text search, and also hybrid search. So let's have a look at the pre-filtering. So basically, imagine that you have millions of vectors in the database, and you are running a query, but you are actually interested in some specific set of data. You don't want to run the vector search query on all of the data. In this case, you can leverage pre-filtering capability to eliminate unnecessary records to be searched. Similar to post-filtering, you make the search first on all of the records, vector search. Before giving it to the client, the results, you can do further processing, further filtering to make the data available to the client. In some situation, especially if the embedding model is not specific to that domain, a vector search may not provide accurate results. In this case, you may try to consider using full text search as well. So MongoDB Atlas is capable of merging the capabilities of vector search and the full text search in one single query to improve the accuracy of the queries. All right, so far we put many components. Now it is time to connect them between each other. For that purpose, MongoDB Generative AI application stack provides the orchestration frameworks, and it integrates with them very well. So LangChain and MongoDB integrates between very well. I'm going to talk about it. And there are some other, semantic kernel and the Llama index also, the other famous orchestration frameworks. So LangChain provides multiple components. The first one is the document loader. LangChain can utilize unstructured I/O library that I mentioned before. Basically, it can automate the activities of extracting data from unstructured data, and it can pass it to a vector store after chunking it. So MongoDB Atlas can be positioned at vector store here. And LangChain also provides conversation history concept. Basically, during a chat, imagine that there are some context, there are some question answer already going on, and this context could be useful for the next question as well. So this conversation history can be stored in MongoDB Atlas as well. Semantic cache is the new capabilities of LangChain. Basically, imagine the RAG architecture. LLM is getting prompts from the vector database, getting questions from the client, and LLM is responding to the question. So there are three elements here: prompts, question, and the answer from LLM. So those information can be stored in a semantic cache, that is MongoDB Atlas. And if the similar question is coming later, it can eliminate going to the LLM. Basically, you can reduce the cost, and you can reduce the latency of your RAG architecture. Did it finish? No. There is another layer. You build this RAG architecture, everything works fine, but how are you sure that your LLM is not hallucinating? It's providing correct reasoning. So for that purpose, Patronus AI company, we are highly integrated with them, they built a platform, they built a solution, great solution. So in the RAG architecture, as we discussed before, LLM responds to a question with the prompts that is coming from vector store. So there are three things. So this can be fed also into Patronus AI, this information, and Patronus AI can use another LLM as judge. So you have RAG architecture here, it already works, and you think that it works very well, but there is another LLM, judge LLM, in this architecture. It evaluates the responses from the LLM. So this response looks good for that question, for that prompt. So basically, after you see this, you can change the parameter in the RAG architecture. You can change the chunk size, you can change the retrieval parameter, you can change the embedding model to improve the accuracy of your RAG architecture. So I have to wrap up, otherwise Dean is going to kick me out. So you can build high-quality GenAI applications faster with MongoDB Generative AI application stack. At the very core, there is MongoDB operational database, highly integrated with the other pieces of the generative AI stack, with the capability of vector database and vector search. With the help of MongoDB Solutions Architect team and MongoDB Professional Services team, sky is the limit. You can build any kind of GenAI applications. Don't forget that the products in this stack can change, as we have already seen with the recent news about DeepSeek, right? Maybe later we're going to discuss different kind of orchestration frameworks or different kind of data pre-processing application products. What is unlikely to change is the need for a great operational database. MongoDB's document model provides and stores, process, structured, semi-structured, and unstructured data easily and faster. MongoDB's cloud-native architecture provides unlimited scalability, petabyte scale, with out-of-the-box high availability capabilities. And MongoDB's enterprise capabilities let you run MongoDB wherever you want in a safe and secure way. I'm looking forward to seeing you developing GenAI applications by using MongoDB Generative AI application stack. Thank you so much. Thanks for listening.